Hello, everyone. Welcome to another Women Tech Makers SSA Spotlight webinar. My name is Onajite Emero Ogwo, and I lead Women Tech Makers for Sub-Saharan Africa at Google. For those of you that don't know, Women Tech Makers is a global initiative that provides visibility, community, and resources to enable women in technology to thrive. Women Tech Makers SSA Spotlight was created to amplify the stories and the pathways of women in technology across SSA. And this series will connect women with economic opportunities in tech by demonstrating specific ways that women can jumpstart and develop their tech careers. Today, the spotlight is on Tejumade Afonja, who's an amazing AI software engineer and the co-founder of AI Saturdays in Lagos. Tejumade will be talking to us about facial recognition in AI, as well as sharing her journey of building a successful career as a woman in technology. Hi, Tejumade.
Hi.
Welcome. Welcome. Thank you for joining us today.
Thank you for having me.
Awesome. So the spotlight is on you now. Please introduce yourself and your topic, and let's get started.
Okay. Finally, we're doing this. Hi, everyone. Welcome. And my name is Tejumade Afonja. I'm a graduate student at Saarland University. I'm the co-founder of AI Saturdays Lagos. And I'm also, this summer, I'm researching at Clever Hands Lab as I'm a research intern as well. So nice to meet you, virtually. And thank you so much for being here. And yeah, I'm going to be talking to you today on a topic which everyone should care about, a lot of people care about at the moment. So it's on debiasing facial detection models. And basically, I'll be motivating the topic, also talking about machine learning, and it's also a technical talk in part. So I'll be showing some some code. So yeah, I'm so excited about this and looking forward to it. Okay, I'm going to.
Okay,
is it okay to share my screen, or you cannot let me know?
Yeah, go ahead.
You see, I'm so excited. I'm just dive right into it. Okay, I'm gonna share my screen now. Thank you. Thank you so much, Ada. Wood, by the way, is in the background. Okay. Yes, super. So, debiasing facial detection model. And I'll be starting this talk by saying a little information about me. So I grew up in the largest city in Africa. It's called Ibadan. And I am Nigerian. I'm 26 years old. I'm passionate about education. I have a goal to democratize the knowledge of artificial intelligence in Africa. I have a degree in mechanical engineering, and I'm currently pursuing a master's degree in computer science. I started learning how to code after my undergraduate studies. I'm psyched about machine intelligence and on how technology can be used to enhance human potential. I play tennis, and I recently, during Corona, picked up the piano. I like volunteering. I consider it as my little way of giving back to my society. And my life philosophy is to never stop trying. Finally, but certainly not finally, like finally for this slide, I would like to live in a society that is just, fair, and a society rid of its bias and discrimination, a society where each and everyone can live up to their full potential. So now that you have some information about me, and I feel like we can get to know each other now. So today I have put up some slides about my talk, and I have this table of contents, which I hope I'll be able to finish. But if not, I hope to have been able to pass the information that I intended to you. And I hope you enjoyed this talk. So the first part of the talk is introduction. We're going to talk about machine learning and bias and some bias model in the wild, and also why should we care about machine learning bias. And the second part of the talk, the technical part, basically is based off the work of Alexander Amini and his colleagues. It's called mitigating. Now, okay, I'm gonna skip that, but I'll get to it. Kind of like I can't remember right now, I'm sorry. But basically it's on the biasing facial detection system, and that's like what the code lab is based off the paper, mitigating bias in facial recognition, facial detection model. Sorry, we'll get to it. And the last part is on, conclusion, acknowledgements, and references. Okay. Introduction. By the way, if you have questions, please, I don't know what the setting is, if you can interrupt me while I'm talking or not, but please do note down the questions and I'll make sure that we have plenty of time. Hopefully we have plenty of time to discuss and interact via the chat. Okay, yeah, I was just told that you can drop questions in the chat. Great. All right, so what is machine learning and how does it relate to bias? And for that, I'm going to, for me, definition of machine learning, it differs depending on what you're asking. And so I decided I was going to go with the Wikipedia definition, which is basically machine learning study is the study of computer algorithms that improve automatically through experience. But of course, there's a lot more going on, but that should do for now. And, bias to a lot of people is a lot of things, but basically you can think of it as like, you can use all these synonyms rather, like unfair, unjustified, like unreasonable, discrimination, all of those things, especially when it's done towards a certain group of people. So I thought to make this concrete, I found this really super short video, interestingly from Google as well. And I really loved it. And it does kind of like give a summary of all that I wanted to talk about today. So I'm gonna play this video. It's 2 minutes.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand-code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, If you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Okay. So yeah, I hope you enjoyed listening to that. And basically the takeaway I want you to have from the video is that, yes, bias is a complex issue and there is no magic bullet. But it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone. So, and yeah, this is deeply personal to me, because like I can't imagine living in a society where technology only works for a few people and not for a lot of people. That is not the society I want to live in. So moving on to the next thing on my slide, which is a question of why should we care about machine learning bias? So basically, machine learning is everywhere, as you might already know by now. It can be used to make, it's currently used in a lot of systems to make decisions, like important decisions in society. And it's impacting our lives daily and the society in general. So, for example, machine learning is used in speech recognition. It's used in facial recognition. It's used in, optical character recognition, autonomous driving, whether or not people can get loan, whether or not people can should have patrol, recidivism. Yeah, it's used everywhere most of these days, but these systems oftentimes are not robust enough for the kind of goal that we researchers have for them. So we need to take a moment to think about the impact of these machine learning tools, and be able to make sure that it's not just working for some people, it's working for all of us. Because if we're not careful what we're trying to solve a problem, we are going to end up creating more problem for the society. So machine learning is so powerful that it can have effects of centralizing power. And I got this point from the talk by Rachel Thomas. And she's an incredible researcher, Dr. Rachel Thomas, by the way. So, and because machine learning can be used at massive scale, and these days it's becoming cheap and cheap by the day as hardware become much more and more accessible. So it can be used to replicate identical biases or error at scale, just like throw in the data and there you go, at scale. It can be used to evade responsibility. An example, a painful example that came to mind was when Robert Williams was arrested in front of his daughter, and he was taken to the station, and they're trying to show him that this is him, and he was like, no, this is not me, and the police were like, but but the machine says it's you. I mean, when I watched that video on Twitter, it broke my heart. It's like, what should we blame exactly? But the algorithm says it's you. So, the people that built the algorithm might blame it on X, and the police would blame it on people that built their algorithm. Like, responsibility, who's responsible here? I mean, so anyway, it can be implemented with no system for recourse and no way to identify mistakes. We just like throw in data, and deep learning is working so well now. It's like black box thing. We don't even know what's going on. Gone are those days when you have to interpret what's going on, when you have to get the features by yourself, and you have to be scrutinized for not getting the right features. Now you can just say it's a deep learning model. We don't know what's going on, which is bad, very bad. So there's no way for the machine to auto-correct itself. It's just like continue to replicate biases and become a nuisance to the world if we continue like this, of course. It can also create feedback loop because we've gotten into the era whereby these algorithms can train themselves. They can generate more data and be used to continue to train themselves. So it's a feedback loop. So you can almost see how dangerous this is if we don't do anything about it. It's going to be a mess. So it can also be used to amplify and not just encode bias. And the reason why I care so much about this is that it's so painful because it's going to affect a lot of marginalized group, people that by default their life is already hard. And we have this technology as a savior, right? Like you bring this tech, we think things are gonna get better, but no, it's only better, but better for some people that their life is not already hard, like people whose life is by default okay. And so it makes me mad because it's not going to be affecting people that are already affected. Sorry, I meant that the other way around. So it's going to be affecting people that are already affected and marginalized, not like people you get what I'm saying? I'm sure you get it. But anyway, we shall move on to the next one. So I'm going to, I just have two examples of some bias model in the wild. Of course, there are so many examples out there, even scary these days. But I wanted to show just to which also Rachel, I got from our talk, watching a talk. Imagine can I go back? Okay. Sorry, let me just confirm. Oh, great, thank you. All right, so I was saying that, so when Rachel mentioned that, I couldn't help but smile. I'm smiling in an evil way because I use a Fitbit and I've been using this Fitbit for more than a year now, and I didn't even know that it's possible that it was not tracking my heart rate. It might not be tracking my heart rate well because of the color of my skin. So and so when I was reading this article and I realized that, oh my God, 16 minutes left. Wow, amazing. Okay, So when I was reading this article, and then it was like the green, like the sensor might not be accurately tracking black skins, but because of the short wavelength, and then it's like the melanin and everything does not allow it to have accurate readings. I would encourage you to check it out. That this is like one example. And then the other one I wanted to show you is the work by Joy and Timnit Gabriel. And like this work was done in 2017, and they found out that some of these facial recognition tools, models out there, or systems out there, they don't accurately recognize people with darker skin color, and as you go more into more and more into like marginalized group, and they realize that these tools feel more and more. So, and the good news now is that because of their work and the way they've exposed this bias, most of these companies have decided to halt the like they're not selling these tools anymore. So you can see this is when you just don't say that, oh no, there's nothing I can do that can change anything. That's not true. There's a lot you can do, because society should work for you and I and everyone. Okay, so how can we mitigate machine learning bias? Is the question, should we collect more data? Or should we be collecting more representative data? I would say the later. But even then, these algorithms still end up learning bias that are intrinsic to in the data set. Like I said earlier, we now apply deep learning to a lot of data, which means that we are given the algorithm autonomous to figure out whatever features gives you the answer you're looking for. So we are not explicitly telling it what to do. We're not giving it these are the features I want you to look for. So the algorithm would learn by itself, and we don't know what it's learning. So depending on the data you throw in, if you give the algorithm in non-representative data, it's going to learn something to make it work. And so so we also need to deal with algorithmic bias, because even though we have more data and we have more representative data, if we have some demographic that, like, on the tail of the distribution, it's going to be very hard for your algorithm, for you, like, to sound like those parts, they will just like be there. Like, you may not necessarily your model might not learn what it needs to be able to generalize across all of the data set that you provide it. So this brings me to the second part of this talk, which is on the code lab. So the question would be, can we uncover and mitigate the hidden and potentially unknown biases within training data? And so as I've already motivated, that algorithm trained on biased data lead to algorithmic discrimination. And we want to have a system that can help us learn some latent distribution of the training data. We want to learn what makes the training data what it is. So is it possible, if we learn that, is it possible that we can use that to reduce the bias in our system, also known as, like, can we bias our models? And this brings me to my code lab, which I'm going to be basing on the work of Alexander Amini and his colleagues. They worked on uncovering and mitigating algorithmic bias through learned latent structure. And I was hoping to go over this technically, but Ada mentioned a few minutes back that I only have 16 minutes left. So I'm going to run through the idea and not in depth. Oh, I'll start to go on. Amazing, thank you. Okay, and all right, it's gonna get a little bit technical now. So, yay, excited. And yes, and okay, so what is latent variable? And I got this image from a MIT deep learning introduction to deep learning course by that was given by Ava, and also one of the cohorts of the paper I'm about to present. And I really loved the way she explained, and I encourage you all to take a look. So latent variable, the way you can try to understand it is that through this image of it's called myth of the cave. So what happened is that we have a couple of prisoners working, and they're not allowed to look up. They are carrying something, and so the only thing they can see is the objects that are casted on the wall. But from their own perspective, they do not know their own reality. Those objects are the only reality they have. Those are their observed data. But in truth, the real objects are what they're holding. But there's a fire that is casting that. So how does that translate to machine learning? So the question, so our data usually have some true underlying factors that we don't know about. So there's a question that can we learn about these objects, for example, that they're holding? Can we learn about them by the latent variable? So the objects that the prisoners are holding are what is called the latent variable. Those are the true objects, but they're unobserved. So can we learn this true representation from our observed data? And so that brings me to another part of the talk, which is on autoencoders. And the autoencoders are unsupervised learning approach for learning a lower dimensional feature representation from unlabeled training data. Imagine we have a data set of faces, for example. So this data set have the data set have true distribution that oftentimes we don't know about the distribution. We don't know how it's collected or whatnot. But is it possible for us to learn a set of some compressed version of this data in such a way that when we decompress this, then we can be able to get back the original data. So and that's exactly what we're trying to do with autoencoders. So you can imagine that we have this data too, and then we pass it through a series of operations, and we get Z, which is a small compressed version of this data. And the Z is what is called the latent variable. It's the same thing as, you can imagine it as those objects that the prisoners are holding that are the true, those are the true variables that represent this data. So in such a way that given this Z, we should be able to get back our data, which is 2. So autoencode, so encoder learns a mapping from the data to a low dimensional latent space Z. And then we can now move from that low dimensional latent space Z back to our original data. But of course, you cannot expect to have the exact data the way it is. You would have lost some of the information. This is a lossy process, but you can still see that it's still a tool. So we're still able to reconstruct our original data. So that's the whole idea of autoencoder. We have a data, we learn a mapping, we get a set of small compressed version of the data. And then when we need the data back, we, just think of it like when you zip a file and you send to a friend. And then when they get the zip file, they unzip it, they get the data back. But in our case, the data comes back not exactly as how we left it. I mean, it's sort of like the same idea with compression, right? You lose some information. So the decoder learns a mapping back from the latent ZID to reconstructed data. And the way this works is that we need to be able to tell our encoder and decoder how do they know if the data is similar. So the learning happens through a loss function. So basically, we take the original data, we take whatever the decoder is giving us. We do we do an elements-wise comparison. So we subtract this from this, like some I was gonna say include a norm, but then I was like, I don't want to use technical term. But anyway, we just take this data and we take the other data and we subtract them to from each other, and then we see, are they close? Are they not? And the loss is what informs us. If they do not, if they are not the same, we continue to rerun the process until we are able to get a loss that is super low. And then at that time, we can say, oh, okay, it seems like we've done a good job in learning the representation for this data. And so, okay, I'm sorry. I can't help myself, Ada. I have a few more minutes left, but so we're going to train the model. So the way we do is that, like I said, we have an encoder, we have a decoder, and then we train the model to use the features to reconstruct the data. And this is the reason why I'm taking you through this process is because this is what is needed for us to for the idea presented in the paper that I mentioned. So the paper used a variational autoencoder, another variant of autoencoder, to learn the latent space, the latent variables of the facial, of each of the face images. So, and then those latent variable are now what is used to help the algorithm, is what is used to help us during the training. I'm skipping ahead now. Okay, so I'm going to give the basic idea of the paper. So here is what happens. We learn the representation of the original data. And then if, for example, the task is face detection, is there a face in this image or not? Very, very simple binary task. But so what we're going to do is that by default, we can do something like supervised learning, where we have a set of data and we have a set of label, and then we learn a mapping from the data to the label. So, but the problem with this is that depending on the distribution of the data we are using, we are not exactly sure if we have another face that is not well represented in the images that we use. We might not be able to detect that there is a face in it. And so I'm going to skip a little bit ahead, just so I give you the basic ideas. I'm talking about this because I don't think I'll be able to go over all of this detail in details. So yes, let's come here. So what we do is that instead of just doing a supervised learning, like where we have X, which is faces and non-faces, and then we learn a mapping. What we want to do is that we also want to learn a mapping. We want to learn the latent distribution of the faces themselves in such a way that we are able to resample data that are not well represented. So what we do is that this part of the update positive probabilities debiasing is that we will from the latent distribution of our images, we will learn which of the images are well represented, and then we will reduce the probability of our input of our the data, instead of us just like getting data and then getting data of images that are super represented. We want to find images in our data bank that are not very represented. So we want to increase those probability. So once we increase those probability, so when we sample, when we sample from our data bank, we are more likely to get images that are much more diverse, and we use those diversified images to learn our task, which is the task of detecting faces. So this is like a semi-supervised kind of idea where you have a data, then this tilde thing that you see here, I don't think you can, oh yes, you can see my cursor. So this tilde thing is what we're saying, that okay, we get a batch of data, which is the input, but the task is to do a classification. We want to detect, is there a face? Is this a face or it's not a face? Yes, we are still going to do the task, but in this this time around, we are doing the task alongside learning the distribution of the images of the face data set itself. I know I wish I had more time. This is a super interesting idea. So we pass the inputs. The inputs this time around, I'm talking about the face inputs. So we pass it through a encoder rather. We get a representation of these images, just like I showed earlier. And then we learn a latent distribution for the face. The reason why there's this 2 bar is that we're trying to say that we only want to learn distribution of the faces, not the data sets that are non-face. We don't care about the data sets that are non-faces. So we kind of like block it for when the label says it is not a face. So once we learn this, we now get a probability. So we use this probability to sample our next batch. So we are not just like getting batch anyhow. Now we are getting batch intelligently. We know the representation of the latent distribution of the data set, and we are using it to sample. And then we are still doing our classification task, which is here. So we just do our classification. So now it's like we are doing 2 things, like we kill 2 birds with 1 stone. If you think about it like that, we can still decide to decode the images if we want to, but that's, if all we care about is the classification, we can literally just forget about the decoder part of the problem. It's just helping us to learn the latent distribution, but once we learn it, that's fine. So the next, so this is the whole idea of the architecture. If you get this, that's super fantastic. But one thing I might add before I jump to like the conclusion is that these things don't just happen by themselves. You need a loss function to guide the training. And the only thing that, the super cool thing is that now we have 3 losses. We have the 1 loss for the classification task, which is what we have here, which is the binary cross entropy loss. And then we have 2 losses for the variational autoencoder part. So this loss tells us that we want to make sure that whatever data we are getting is the same, like it's the same reconstruction. So it's called reconstruction loss, just like what I showed you earlier. But I didn't go through variational autoencoder, which is what brings us to this third loss. So the third loss is telling us that I just like this latent thing that you're learning, I want to make sure that you're not cheating here, man. Like, I mean, why did I say man? Anyway, I want to make sure that you're not cheating here. So I want you to learn and make sure that the latent distribution you're learning follows a normal distribution. So you can think of this as the prior. So we are kind of like constraining the algorithm to learn something we wanted to learn. So it's also called Cooper-Kleeblatt divergence, like KL divergence, and you often see it in the literatures talking about this. So these are like these three losses help us do the magic that we need for this to work. And yeah, so basically I put more things here just like to explain to you what's going on, but I'm going to go to show you some results perhaps. Yes, so this is what happened. The task is facial detection, like I said. So given a set of positive faces and negative faces, training example, sorry, not negative faces, negative, I made a typo here. Negative training examples. Our goal is to ensure that the set of positive examples used to train the classifier is fair and unbiased. So look at the faces, and it's gotten from the celeb A data set, and the not faces gotten from the ImageNet data set. So after we do the debiasing, before debiasing, by the way, this is the results from the paper. I just like cut it and put it there. So we sample random batch sample before debiasing without the algorithm. This is what you get. But once we learned a debiased model, you can see that we have more representation, diverse skin color, pores, illumination. And I also ran the experiment myself. Like this was like what I got. Of course, I didn't do any hyperparameter tuning. So, but this was exciting because this is former president of Nigeria, so President Jonathan. So I wanted to use this picture. And so, but to me, it looks much more diverse than this. You know, these are some of other results from the paper. If you're really fascinated about this, I'd encourage you to check it out. You can even chat about it because I really love reading this paper and preparing for this talk. And so they also noticed one or two more things I'd like to say before I leave. I'm sorry, Ada. And then it's that. So when look at this result, it's fascinating, right? You can see that even with the bias model, we are still, it's not like this is solving our problem miraculously. You think that, oh, once we've done this, now everything is fine. We can sit and relax and just like use the algorithm of the show. But no. Oh no. I was just told you can't see the results. Okay. I can see it. I'm not sure. Is it back? Can you see anything now? What can you see? Oh, okay, I can keep going. Thank you. So you can see that even though we use this, of course, it's the accuracy is increased significantly from no debiasing to very debiased model. But we also notice that dark male still has the lowest accuracy from the data set that we use. This is because it's not well represented in the data. So, you cannot sample what you don't have, right? Like, even if you use this algorithm and then you don't have this data, like, what do you do? It's not just miraculously going to get this, unless, of course, if you use like a generative model to generate this kind of data and then add it to your training pool and use it to retrain. You can do all other amazing things with GANs and all. So the question was that why didn't the accuracy for dark male improve significantly? And I just mentioned because it's not well represented in the data that they used. And in conclusion, I know I went over this real quick. I hope I hope you still got the point. But in conclusion, deploying a fair, unbiased AI system is critical to their long-term acceptance, and the manual annotation might not capture all the features that are imbalanced within the training data. Having the representative data is crucial to train an unbiased model. And I want to leave you with this last quote from Joy, and she said, and I quote, "We have entered the era of automation, overconfidence, yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine learning. Under the guise of machine neutrality." So, and I hope you take this to heart and continue to do amazing stuff, and also take into consideration the effects of this, the tools we're building, and I also wanted to acknowledge some of the people who are really dear to me, and Timmy Gabriel, my professor Nicholas Papenard, Sarah Uka, my team AISS the Lagos, Data Science Africa, Black and AI, Deep Learning Endeavor. I want to say shout out to the MIT 6.S191 team for the amazing video, Alexa Damini and Eva Sulaimani. And I put the references, which I'm not sure you see anymore because my time's up. So, questions?
Wow, thank you so much, Tejumade. That was a lot.
That was too short. I want more time.
I know. I wish we could do a longer session. Maybe another time when we have a lot more time. But we try to keep these webinars quite.
Thank you. I was just super excited. I want to share everything.
I know. And I was really I was just sitting there like, wow. All of this is so amazing. And I'm sure everybody watching, feels the same way as well. That was really, really good.
I hope so. Thank you. Anyway.
Yeah. Of course. Yeah. So thank you so much, Tejumade, for sharing that knowledge with us. But before we go into any Q&A or anything like that, wanted to first of all learn a little bit more about your journey. I know you shared some things at the beginning talking about university, but what we want to know is what really motivated you to actually go into technology, and what inspired you, and why did you focus on AI?
Oh, okay. Yeah. So, like I said earlier, I have a degree in mechanical engineering. So, and as far as I can tell, I wanted to become an engineer. And I remember now, it was because people always said things like, female can't do things. And I was like, well, no, it's not it. So I always wanted to do something that was hard, that people thought only male could do. Like when I was younger, I used to play football. People would tell me I was behaving like men. I just really found it weird that I felt like I needed to prove myself that I could do things. So I wanted to go for the hardest thing. I thought, like, now I know better. Like there's nothing like engineering being hard or like other subjects being not hard. But then it was more like people felt like mechanical engineering was just like female cannot cope in it. And I was like, no. Yeah, so I studied mechanical engineering, but while in my 200 level days, even though like I've always been good at math, I loved math, like I loved I'm technical in mind. I've always really enjoyed reading stuff like that. But I just thought to myself that I wanted more. I don't know what was happening, and I was like, I was just fascinated. I was studying somewhere, and then there was this society, IEEE, which is Advancing Technology for Humanity. So they had their meeting. I didn't know anything about them before then, but I usually study in school. So they were going to have the meeting where I was studying. And it takes a while to get another quiet place. I like sitting in a quiet place. I was just like, I'm just going to wait here till they leave. And they said it was okay to wait. So they were talking that day about robots, like the Mars Curiosity robots, and they showed pictures around. I don't know what happened at the moment. I looked at the picture and I fell in love, if that's a thing. Yeah, I don't know. I just looked at the picture and it felt like a fascinating thing to be able to build a robot or like intelligence. And that was when the idea, so I like the question stuck in my mind: can machine think? So that was like, I mean, that was the only question I was trying to answer in my mind throughout my undergraduate studies. I wanted to like build machines that can think. So as I grew more into the field, of course I joined the society. My final year thesis was on robots, vacuum cleaner. So I was in the robotic society and all those stuff. But what happened was that I started to realize that I was very, very passionate about the intelligence part of machine, and I didn't have that training. I had the training in engineering. I never really found that part of it. It was harder for me. The intelligence part was hard because I didn't know how to code at that time. So I started learning how to code, and I started learning more about artificial intelligence, and then that was how I got into like artificial intelligence, because I wanted to learn to build machines that can think. And then, but as I grew more into the field and, I saw the impact of technology in the society, and how these tools can help make life better if used in the right way, if deployed in the right way. So that was like where my passion started like coming into. Now I'm passionate about algorithmic bias, privacy, security, and that's what my research is like towards. Like I'm currently researching at Clever Ants Lab under the supervision of Professor Nicholas Pipanels from the University of Toronto. And in the lab, all we research is like most of our question is on privacy, security, and machine learning. Like, how do we make sure that the systems that are like out there and are not things that are like can be attacked? And then we are like investigating most of these things. So yeah.
Wow, that is really, really amazing. So what would you say to, a young girl that's in her 200 level, thinking of what to major in? How would you advise her to start, looking at artificial intelligence and machine learning? Like, what would be the first thing you would advise her to do with your own learnings?
I think it was really nice to be in a society. Like, what I mean is that a community at a young age, even till now, I've always been in a community. Like when I was in school, I always attended like the Google events. Like when I finished school, I still attended a bunch. When now, I co-run the community, I volunteer to a lot of stuff, because though it's kind of like open your mind to see what other people are doing. Like you cannot learn in silo, and it's boring. Like you want to having a group of people kind of like inspires you, and it makes you feel like you can do anything. So to a young girl out there, I know some of the things I struggled with was like me trying to like define my place in the world, and kind of like for the longest of time, I felt like people told me whenever I wanted to learn something, because I was studying mechanical engineering, if I was interested in learning to program, they'll tell me, why am I trying to learn to program? I'm a mechanical engineering student. So for the longest time, it stuck in my head because I felt like I was not supposed to do this. So I never felt I'm encouraged, because I always felt like I was doing something outside of my field and I shouldn't, like it was something that was wrong. I wish I knew, I know better now, but it would have been nice if I kind of like understood at that point that I can just like go wild with my imagination and just like see what I like. like the society or like whatever opinion people have of you, like kind of like want to constrain you. And at a young age, it might not be easy to break free. You don't know what that is. You don't know who your own person. But I hope I would like to the young girls out there. It's just like just be free of those limitations that the society wants to impose on you. They don't exist. If you want to find out something, like the best way to discover what you're passionate about is to find it out. And if it doesn't work, it's fine. Like, I mean, there was when I was 21, I told myself it was exploration stage. Like, I failed a lot. I was like, it's fine. I'm 21. I'm just gonna like. I mean, I still find failing now. Like, I'm 26. It's just like it's okay. Whoever told you have to be something like nobody gave a playbook to life. So I'm gonna like figure this shit. I'm sorry for the language. So I'm gonna figure this out, like, and until I am satisfied with my own person. That's all that matters. And so you're young. I mean, it's never too late. Even when you're old, just kind of like explore, find out what you like, and then and it's okay if down the line something changed and you need to change it. It's fine. It's just like you've learned, you've grown. The experience will always stay with you forever. So
awesome. So while I'm here battling with some electricity issues, I'm just going to ask you one last question.
Okay.
And I'd like you to just give us, a short, concise answer. So at Women Tech Makers, we are focused on creating a world where all women can thrive in technology. And so today the spotlight is on you. Based on your experience, what do you think is needed to make this happen?
Well, this is a tough question. And I'm not a very concise person. Like, my mind just goes wild. But I jotted something down in advance. And I'd say, first of all, of course, like mentorship. Like, it's just very important. Like, I know a lot of people's like, you don't find mentor, but to be honest, like, it's good for someone like to feel like they're like someone who's champion, like who's your champion. Like, it doesn't even have to be explicit, or someone that asks you about your career journey. They're kind of like interested in your career life. It's a good motivation. It's okay if you don't have it. I'm not saying you're not going to survive. Of course, there are a lot of people who are doing well without mentors, but I'm not sure if that's like entirely true. This is how everyone has someone at some point, but I'm just saying mentorship is important. Like, be a mentor to someone, and also if you don't have to make it formal, just kind of like check up on other girls, see how you can help them advance their career. I also had this thing like about like self-confidence. I don't know how Women Tech Maker can help with self-confidence, but just like I think through this kind of like spotlight talk, right? Like, when you see people that look like you kind of like boost your morale a little. It's like, if she can do it, I can do it. Yeah, that's what I want to leave you with. If I can do it, you can do it. You've got this, girl. Around the world. Anyway, so opportunities. Yeah, you should always give women opportunities. I hate this thing where that you say, you have this role, it's technical, but we are looking for some people, but like she's not like we only have 3 slots, but all the men are more technical. I don't care what you're trying to say. I'm saying that like this thing about gender equality, everyone needs to play their part, and it means that you have to be intentional about it. So if you have 3 roles that you want to fill in and you cannot find any women that has the skills that you're looking for, you have better start looking for one, like picking women that you're going to train to get where you want to get to, because everyone thrives when given the opportunity. Like, I think become who I am today. It's because a lot of people gave me opportunity to grow, to become my own person, to be comfortable with myself, and everyone deserves that chance. So you had better start making that room for people to feel comfortable in your organization, because it is inexcusable that you have 2% women. Nah, that is wrong.
Yeah.
So
yeah,
we gotta do something about it. Yes, yeah, opportunity. Yeah, I think that's, I mean, we can wrap it up with that. Yeah.
Awesome. So thank you so much, Tejumade. That's actually all the time that we have for today's Spotlight session.
Yeah, thank you for having me.
So thank you to everyone. And a big thanks, big thanks to you, Tejumade, for joining us today and sharing all of this knowledge and your experience with us.
I'm sorry I couldn't take questions.
So if anybody would like to learn more, of course, but yes, please follow Tejumade on Twitter. Teju Afonja is her Twitter handle. And if you want to learn more about Women Tech Makers as well, please check out our website, womentechmakers.com, or follow any of our social media. We're on Twitter, we're on Facebook. And you can also join a community near you. Like Tejumade said, joining a community is super important for every single woman in tech.
You don't have to do it alone. You don't have to do it
Awesome.
Thank you so much for having me.
All right, bye.
Bye. Thank you so much. Thanks, everyone. Thank you for joining. Bye-bye. Take care.